Welcome to the fourth lesson on organic chemistry. So far, we've looked at the introduction to organic chemistry. We've also looked at alkanes and alkenes. In this video, we're going to take a look at alcohols. Then in the next videos, we'll look at carboxylic acids and esters and also polymers. Let's get started. So alcohols are also called alkanos. Their general molecular formula is CnH2n plus O1 OH, which simply means if you have, for example, 10 carbon atoms, then the number of hydrogen atoms you're going to have is 2 times 10 plus 1. So 2 times 10 is 20 plus 1, 21. So you're going to have C10, H20, H21, and then you add OH. So N can be numbers 1, 2, 3, 4, just like that. The functional group is hydroxyl group, which is of course single bond OH. In short, N alcohol has OH, which is single bonded to the carbon atom. So they all end with ano. They are not hydrocarbons because they contain oxygen. Alkanes and alkenes are hydrocarbons because they only contain hydrogen and carbon. Well, alcohol has oxygen, which makes it not to be a hydrocarbon. Here are some examples of alcohols, their molecular formula, structural formula, and the condensed formula. So methanol, which has 1 carbon atom. So how many hydrogen atoms do we expect? So CnH2n plus 1. So 2 times 1, 2 plus 1, 3. Then OH. So the structural formula, we just have carbon. Actually, when you're drawing the structural formula of alcohols, you better start with carbon and OH bonded. Then you fill the other parts of carbon, the other 3 remaining bonds with hydrogen atoms. So this is the condensed formula. So I'll skip from here to the last one because you know what we do here. We'll just be going through. So we're going to do that, but this one, since it has more carbon atoms, maybe we can learn a thing or two, but I doubt because we already know this. So I have butanol here. So butanol, but is the prefix for 4. So I mean that 4 carbon atoms. How many hydrogen atoms? 2 times 4 plus 1, 9. Then OH. The structural formula, when drawing it, you start with carbon, then you connect it to the hydroxyl group. Then you populate the other parts with hydrogens and carbons, making sure that you have 4 carbon atoms. Then you connect them. Then the other part you populate with hydrogen atoms, making sure that each carbon atom has 4 bonds and each hydrogen atom has a single bond. The condensed formula, you can just get here as this is CH3, this is CH2, this is CH2, this is CH2, this is OH. So since we have 3 CH2s, so this is going to be CH2 in brackets and a 3, which is the CH2 in brackets and a 3. We go to preparation of ethanol, just like we did with alkanes and alkenes, where we just took one homology of that homologous series and used it in learning how to prepare, keeping in mind that the preparation method are the same for the other homology. So I'm using organic chemistry language here. I'm sure you are able to get. So preparation of ethanol, there are 2 methods of preparing ethanol. So there's what is called hydration of ethene. So this hydration, when we are doing ethene or alkenes, we discussed it. We talked about 2 types of reactions which alkenes undergo. One of them was addition reaction. On addition reaction, we also discussed about 3 different types of addition reaction. One of them was hydration, which is basically adding of water to ethene. You get an ethene, you add water, then it becomes an alcohol. However, the water is usually in the form of steam. So ethanol can be prepared when ethene reacts with steam. So we have ethene here reacting with steam, forming ethanol. So using structural formula, we have this ethanol, ethene reacting with water to form ethene. And what happens here is when you hydrate ethene, this bond is going to break so that we have a single bond here. Then the carbon atom, this carbon atom is going to form 1 bond, and this carbon atom is going to form 1 bond, because carbon atoms always need to have 4 bonds. So when this forms a carbon atom, is going to connect to the one hydrogen atom from water. Then this one is going to connect to the OH, which is this one here. The other method is fermentation of sugars. So this is something that we should be familiar of. Okay, those who bake should be familiar with. So fermentation of sugars. Fermentation is just a decomposition of sugars using enzymes in yeast to produce ethanol and carbon dioxide. So this is the same process that the baking of vitumbua is made use of. Also, the baking of, not the baking, the brewing of beer. Also, they use fermentation. So sugar or glucose is mixed with water and yeast. Sugar or glucose is mixed with water and yeast and allowed to react for a few days in the absence of air. So note the conditions here. They get sugar, water, and yeast. Then they are mixed. Then they are allowed to react, but in the absence of air. Why in the absence of air? So I'm going to discuss why air is not needed. What can happen if there is air? So the reaction is glucose just breaks down to form ethanol and carbon dioxide. So what makes glucose to break down? Why can't it just break down on its own? So the enzyme in yeast makes glucose break down. Without this enzyme, this cannot occur. So this is the reaction. Glucose breaking down form ethanol and carbon dioxide. So to make this possible, I've already emphasized the points. The first is the optimum temperature should be 37 degrees Celsius, and the second is the catalyst should be zymase. So for the catalyst, the enzyme, I've talked about it. It is found in yeast, and it is the one that makes it possible for glucose to break down. But what about the temperature? So most enzymes work best at temperature 37 degrees Celsius to about 40, but not above 40. So the optimum temperature is 37 degrees Celsius, and at this temperature, that's when this enzyme works best. So what happens if you if the temperature goes too high, above 40? So there are two things that we are always avoiding. Why? Make sure that there's no air. Two, the temperature should not go above 40. As an emphasis, fermentation should take place in the absence of air to prevent oxidation of ethanol to ethanoic acid. So if there's air, ethanol will turn into ethanoic acid once oxygen combines with ethanol. So that's why we don't want air. Second, if the temperature goes above 40 degrees Celsius, the enzyme in yeast which catalyzes the reaction becomes denatured. To become denatured is to be distorted in shape. So when enzymes are denatured, when they are distorted in shape, they can no longer participate in reactions. So now take a look at some physical properties of alcohols, which maybe I know I don't expect people to drink, but I'm sure you have seen some sort of alcohol with your eyes. Though maybe you might be surprised, but let's take a look at some physical properties of alcohols. First, they are colorless, inflammable liquids. So alcohols, pure alcohols, they don't have color. If there is an alcohol that has color, it means there is a coloring agent that has been added, or there are some other particles that are not alcohol. But normally alcohols don't have color and they cause fire. That's what inflammable means. Their boiling point increases as the carbon chain increases. So this is something that should be intuitive. We expect if the carbon chain increases, we expect more heat to be added for the bonds to be broken. That's the reason why the boiling point increases as the carbon chain increases. Their solubilities in water decreases as the number of carbon chain increases. Again, this we should also expect it, as the number of carbon chain increases, meaning that it might be difficult for the solvent to dissolve the solute which has more carbon atoms than the one which has less carbon atoms. So the solubility decreases as the number of carbon chain increases. Chemical properties of alcohols. So the first is the one that is common to all organic compounds that we have discussed, and that is combustion. So alcohols burn in air, meaning that they react with oxygen to form carbon dioxide and water. Remember the types of combustion: 1, complete combustion; 2, incomplete combustion. We won't go into those details, so I'm just going to talk about the basic combustion, where we assume there is enough oxygen and carbon dioxide and water are going to be produced. So this is an example of such a reaction, where we use ethanol as an example. Ethanol plus oxygen produces carbon dioxide plus water. And using chemical symbols, we have this. So this reaction is exothermic, which means it gives out a lot of heat energy. So alcohols, that's why they're inflammable, because of this reaction, which gives out a lot of heat energy. The second is oxidation. So this oxidation is the one we were trying to prevent when we were doing fermentation. Ethanol can be oxidized to ethanoic acid by bacteria in the air. So long as there is air and there are bacteria in the air, they can oxidize ethanol to ethanoic acid. So this is the reaction where ethanol turns into ethanoic acid and also produces water. Ethanoic acid can also be formed by using an oxidizing agent. So let's say we don't want to use this bacteria, or let's say we're in an environment where we don't have this bacteria. What can we use to turn ethanol into ethanoic acid? We use oxidizing agents such as acidified potassium permanganate and potassium dichromate 6. So these oxidizing agents are going to bring in oxygen. This oxygen is going now to react with ethanol to produce ethanoic acid. As you can see, both of these examples I've given, they have oxygen. This one has 4 oxygen atoms, this one has 7 oxygen atoms. So the same reaction, where ethanol reacts with oxygen to form ethanoic acid plus water, and the oxygen comes from the oxidizing agents. So in this reaction, here are some key points to note. When ethanol reduces potassium permanganate, for example, the reaction is indicated by the color change from purple to colorless on mixing. So when you mix ethanol and potassium permanganate and there is oxidation, then the color of the mixture is going to change from purple to colorless. Also, let's say we don't use potassium permanganate, but we use potassium dichromate. The reaction is indicated by the color change from orange to green on mixing. Okay, so if we're using potassium permanganate, the color will change from purple to colorless. But if we're using potassium dichromate, it will change from orange to green. So when the change occurs, then you know that oxidation has taken place and we no longer have ethanol, but we have ethanoic acid. And we finish this with uses of ethanol. First, it is used as a component in beer and wines. Second, it is used as a solvent. Third, it is used in making methylated spirit. It is also used as a fuel. So these are some good uses. Some of them you're familiar with. For example, used as a solvent. So there are some compounds that dissolve easily in alcohol, such as I think there are some compounds we learned some time back which dissolve in alcohol, but not in okay, I think I remember one which dissolves in organic solvents but not in inorganic solvents, and that is covalent compounds. Okay, so covalent compounds dissolve in organic solvents but not in inorganic solvents, while ionic compounds do the opposite. So that's what it means as being used as a solvent. Then used as a component in beer and wines, we already know that. Used in making methylated spirit, we know this. There's methylated spirit which is bluish in color. That one has alcohol. It is also used as a fuel because when you combine it with oxygen, it burns. It is flammable. Because of that, it is used as a fuel. It is also used in the preservation and sterilization of food. So this marks the end of lesson 4, and in the next lesson we're going to take a look at carboxylic acids and esters. Then we'll finish with polymers and we'll be done with chemistry. Happy fighting!